Well, this is the main drilling event for our business throughout the world. It alternates between the US and Europe, obviously. And this is where the drilling people really come together to talk about what's changing, what's new in our industry, how do we improve, how do we get better all the time. So this is the big event for the drilling community.
Hi, and welcome to SPE Live and today's broadcast Beyond Automation in Well Construction. We will be shortly meeting our experts today, Francis Besnard and Alexandre Jourde from Schlumberger. We are talking about autonomous drilling operations. So what lies beyond drilling automation? Our complex subsurface and dynamic drilling environment for well construction requires more than just automation to deliver consistent performance improvements. This is our Tech Talk today. You have questions and comments on automation and autonomous drilling systems, then please start posting your questions now. We want to hear from you. My name is Nils Kaageson-Loe, and it's my pleasure to be your host for today. And if you're new to SPE Live, check us out on social media, #SPE Live, or find us on SPE.org. We have a busy schedule of SPE Lives coming your way. Look out for all of these on social media. You can check out all of our 2020 catalog for free at your leisure. So please enjoy that. And now let us meet our guests today. We have Alexandre Jourde, Well Construction Digital Program Manager at Schlumberger, a 22-year veteran with Schlumberger. He has held various positions in Europe, Africa, and the Americas. Joining him is Francis Besnard, Digital Well Construction Technical Marketing Manager at Schlumberger. Prior to his current role, Francis was VP Well Engineering and Technology for Schlumberger, and over a 21-year career with the company, he has held various technical and management positions across Europe, Africa, Asia, and also the Americas. Alexandre, Francis, welcome to SPE Live. It's a pleasure to have you joining us here today. Good to see you, gentlemen. Thank you.
Good morning.
So, today's conversation, world of autonomous operations, so beyond today's drilling automation. So just a quick reminder to our audience, please share your thoughts and questions on social media here, fingers on buzzers and keyboards. We'd love to hear from you, get your comments and questions coming into us. So to kick us off, Francis, I'm going to start with you. If you can tell us a little bit about the complex subject of autonomous drilling operations. I know that you've been working on a classification of degrees of autonomy for drilling and well construction operations. Can you tell us why this is important to define such a system?
Sure, thank you, Nils. Well, the reason really is very simple. It holds in one word. It's all about value, really. So the value of autonomous systems is quite apparent, quite obvious to most of the actors of the oil and gas sector. This journey started over a decade ago, a long time ago, yeah, and everyone's been working on this. And while everyone can, rightly claim to have automated technologies, it's just not always clear what's the value being delivered. Yeah. So in short, this is really about having a measurement of this value. So to simplify this, we could say that the value is a combination of two things, really. First thing would be the extent of the workflow being covered. That is, are we talking about something very useful, but maybe a limited feature? Or are we talking about a complete and consistent process? And obviously, the end result is very different. Yeah. The other factor is the degree at which the process has been automated. A higher degree, you will think, will generally translate in an improvement in consistency and in performance. Yeah. So the value being a combination of these two things it gets important to actually really to be able to understand what value it brings, to bring some sort of nomenclature that will help us define a unified terminology for automation as well as autonomy that is going to be consistent and clear, and that's also going to be paving some milestones along the journey that we're taking to autonomy. Yeah.
Okay, thanks, Francis. So yeah, you mentioned there the sort of nomenclature and the importance of that in terms of defining the systems, and really also about the extent of what is the value behind the automation and the autonomous systems. Over to you, Alex. Where do we go from here? How can we build upon these levels of automation from other industries to achieve autonomy within drilling systems?
So yeah, you're right, Nils. So what we did, we started by looking at the automotive standard for autonomous vehicles, and we believe that it was a very good place to start, right? And I think it would be the reflex to a lot of us. And so why is that? First, they're one of the leaders in automation, and they've grown a very solid body of knowledge over the years, right? And I would recommend you to read that standard J3016 that you can see on the next slide, actually. So they also have to manage a great level of uncertainty. Automobiles, unlike a plant, they operate in a non-repetitive environments, and so they have to define technology blocks, which are some of the technology blocks that we're also using in our own systems. Like when you look at the way you plan for a trajectory or for activities, the way you need to infer what the state of the world is, what is happening around you. So these are very important things. So we had to align with this, and also they looked a lot at how to hand over back the control to the user, which is also something we want to use. But we have a different focus, which is also performance, right? On a car, you want to go from A to B, and how fast you go is probably not the greatest element. And so to achieve that, we also have to have a greater focus on planning, which is somehow a balance, if you will, between performance, quality, and risk, right? How do you balance all those things? And that planning aspect is not as important. And especially the planning looks at another thing, which is the deliverable. The deliverable when you're in a car is getting safely to your destination. In our case, it's we all know it's much more complex than that. And also, you never drill the same well twice. You never know what's happening, in the next foot or next meter. That anything could potentially happen. And finally, and I think that was probably one of the biggest element too for those degrees, is that it's not a one-man show unlike driving. We have a lot of métiers collaborating on the well site. And you need to think about how all those métiers will collaborate, if they're within the same system or if they're in a different system. So those degrees had to define that. So that's why we had to define those degrees of autonomy.
Thanks, Alex. So Francis, continuing on from what Alex has said there in terms of the degrees of autonomy and particularly the non-repetitive environments that we're working in, can you say a little bit more about what are the degrees of autonomy behind all this?
Yeah, sure. So we've structured our development and our roadmap towards autonomy around 6 key levels of autonomous capabilities. Yeah. Now, what these are is they're a shared framework within Schlumberger. We work with those, and they're also aligned with other industries. And Alexandre mentioned earlier the automotive industry, the space industry. These levels will help us ground our technology development into some steps that are very tangible and that are a milestone to achieve a vision. Yeah. So if you look at that slide from the left to the right, at the level 0, the humans are fully charged. Quite simple. They've got a little bit of assistance from alarms, yeah, but this is the level that we're all very familiar with, really, at the lowest level. Now, at the level 1, we're moving to assisted operations, yeah. So that is, the system can implement a simple regulation loop. So we can talk about examples later on in the discussion, but if you just take the example of the auto driller, all it does is maintain the weight on bit, for example, or maintain the ROP, for example. So that would be like a level 1 assisted operations. At the level 2, singular workflow automation is going to start taking place. Yeah, and I insist on singular workflow. It is something very limited with the beginning and the end. The system provides some context data to help the decision making, but humans are still in control of the complete operation there. Yeah? So if you just take the other example there, the auto driller, we said that the auto driller just got a little bit smarter as to what's the best weight on bit that should be used. Yeah. Anyway, you move further to the level 3, and then this is a different world. It's a leap forward. You're moving to the autonomous world, yeah, where the system is going to be self-regulating, and there'll be a no human intervention for a singular workflow. It isn't about everything's one singular workflow we're looking at. Yeah. Now the level 3 is going to be often a combination of multiple support features, and is going to be unifying them. So what we have there is a system that we call an adaptive system. It's a system that supports some level of analytical decision making within the automation of the process. Yeah. So the system has an awareness of the workflow considered, this one in particular, and it's helping us make the decision. Yet the user is still engaged. Yeah. And so the user, he or she, will ensure the system is delivering the workflow as per the expectation based on this. And then if you go to the level 4, which is the next level to the right, yeah, this is going to combine multidisciplinary well construction workflows, so multiple workflows. Now, by multiple, you start at 2, but there's a lot more than those, 2, 3, 4, 5, etc. And it could be multidisciplinary. Yeah. So this is something that's very specific to the oil and gas industry. It doesn't happen in the automotive industry. We've seen this earlier on. Yeah. So there's we have different disciplines and different métiers that are going to collaborate right at the well site, and there's going to be different actors in charge of them. Yeah. And you can think the man driller, directional driller, etc. Yeah. So practically, what does that mean? Well, if you take the example of autonomous directional drilling, for example, we see that the driller and the directional driller, they're constantly talking to one another, they're interacting, and they, of course, they won't deliver the best possible well, but they need to talk. Yeah. Now, if you automate the tasks of these two stakeholders and you do that independently, then, of course, you're going to have something that is suboptimal, and that's worse. It will fail. Yeah. Now, at the level 4, the system is autonomous enough that it's able to manage this constant interaction between workflows, which is why we call it, orchestrated workflows there. Yeah. So at that level, the driller basically is hands off, minds off, and the system is managing the fallback. Yeah. And then you get to the level 5 to the far right, where this is the wall, full autonomy. Yeah. This is the ultimate achievement, where system is going to surpass the user in the ability to deliver workflow. That is, in terms of decision making, in terms of execution, the machine will do better than the human. Yeah, it will have, be adaptable to any kind of situation, be able to make the decisions, and we see that the decision making is very important part of this journey to autonomy. Yeah, so whatever complex the environment, the machine will be able to make that decision. Now, there's another aspect to this as well. Is if you're dreaming or you have a vision of getting there, you must think of the planning. There's going to be another level of planning that must go into this. It will have to be very, very well defined. If you don't define well the expected outcome, then you can't reach that. Yeah. So all these levels apply to well construction in general. So you have singular workflows, but like I said, there's many of them. So if you combine them all, directional drilling, drilling fluids, mud logging, cementing, all these workflows working together. Yeah.
Thanks, Francis. That is a very intriguing description of the different stages of the autonomous levels. So I'm going to come on to audience questions in a minute, but turn to you again, Alexandre. So we get also demanding and complex staircase to navigate. What does it take to go up these degrees of autonomy for well construction operations that Francis just described? I mean, it seems simple, yet also complex, right?
Yeah, so you can't get there without building a different system, or a system that has different components, right? So if you we're going to start from the bottom down, right, from the rock. If you look at what you can do downhole with downhole automation, you can actually accelerate decision making by eliminating the latency time that you have of the tool exchanging information with the surface. So whatever we can place there, we will place there, which is one set of technology. Then you have another set of technology at the surface, and that's and there's a lot of equipment at the surface. You can see on the picture here. You have the rig, and so you need to have your digital acquisition system. You need to define an interface with the rig control system, but also with other equipment that can be there. And then you can take care of different workflows such as demodulation, downlinking, energy management. If you have drilling dysfunction as well, like a stick and slip and shock and vibration, you can take care of them. You can look at mud analysis, cutting, samplings, analysis, etc. But there's so much you can do by just automating there, right? And especially in that, and I guess if you do only that, you probably stay around level 2. If you really want to elevate, you need your system to be smarter, and we have a lot of technologies now at hand that allow us to do that. So you need your system to be adaptive, and you need your system to be cognitive, and that's what we call intelligent execution. And think about, for example, how you analyze data in real time in order to identify potential hazards or recompute your trajectory or your sliding instructions. So that's what you can do. But then there's another step, which is building that intelligent planning level, because I mentioned planning is an important part of what we do. We do replanning even during the well, a bit like your GPS in your car. And so we also need the help of those machines to help us make better decisions. And so we need them to help us. For example, we've been working on offset well analysis and automated trajectory design. We believe all those 4 blocks are really critical in getting up the levels, and we may be stuck somewhere in the scale if you don't apply them. And there's one more thing I wanted to mention is we've been working on 2 platforms actually around those 2 that we call DrillPlan and DrillOps. DrillPlan being focused on the planning aspect, which is a collaborative environment for our engineering team or our clients team, and DrillOps that is more focused on the execution, right? And DrillOps is being deployed at the well site or in the cloud.
Perfect, Alexandre. So really great sort of outline of this journey to fully autonomous operations. Now, the pair of you mentioned earlier how a lot of this has been sort of constructed around experience and knowledge from automotive industries and space industries. I'm also reminded of aerospace. We've had automated planes now since the late 70s, I believe. So, planes can basically take off, fly, and land automatically with no interaction from the pilot. So how much can we learn from that industry? Because that also requires a certain element of planning and risk management, that you alluded to in your presentation. Francis, do you want to take that, maybe?
Yeah, absolutely. So this is interesting. But if you look at those degrees of autonomy, they're not really just for the well construction or just for the oil and gas sector. Now, there's different industries that will have different variations, different levels. I think the space industry has got a reduced number of levels. There's nothing more automated or more autonomous, I should say, than the space industry. Landing on Mars just recently, you land there, and you got a certain number of tasks to do the next 2 years, and that requires the highest level of autonomy, obviously. Yeah. The interest of this is that for the well construction and the drilling domain, this is going to pave really the different steps as we go and get there. It's not going to happen in one shot, obviously.
Thanks, Francis. Alex, do you want to add to that, maybe?
Yeah, I think what is interesting is to realize that different industries have different drivers, right? And so I think automotive industry is, when people are very focused on that full autonomous cars, because this is really when things start start changing dramatically. On the, if you're looking at a plane, I guess it's again a different driver that is probably more related to improving the level of safety, i.e. making better a decision than the pilot while still having a pilot in the plane. And so, and I think I mentioned that before, but our driver is performance. So because of that, the systems will look at slightly different. But I think we need to recognize that, and then I think in our case we need especially to recognize the importance of planning and measuring that performance. That is a critical aspect, and how can we get performance improvements as we go along? And I think that's the focus of the whole industry.
Perfect, Alex. So that really helps pick up from an audience question here. So from LinkedIn, what is the main objective of automation technology? Now you mentioned there it's performance driven. So you also earlier mentioned what is the value behind the automation and your autonomous systems, or the drive to autonomous systems. Can you sort of maybe give us a little bit more detail around that? You mentioned performance. So what is the main drive behind this?
So yeah, I think it's, I mentioned performance, but that may be a bit of a shortcut, in the sense that we know that you don't get to performance straight away. You know that in order to get to performance, you first need to get to consistency. And I could see there was somebody mentioning Six Sigma, and there's an element of that as well, right? Which is those two go hand in hand. And we believe that first you need consistency in order to then get performance, and especially you need consistency because consistency allows you to learn much more. It's very difficult to learn today because of the inconsistent practice that we see in the industry. Within two crews you can have on the same rig, you can have very different practices. So learning from that is then very difficult. So I think it's consistency is also one of the things that we need to start learning to measure and appreciate. And then use that to push the performance.
Perfect. That picks up on another audience comment here already. Is it oriented to optimize current practices towards more consistent execution, or is to provide people with more headspace? So I guess it's a bit of both, right? So initially it's going to be more consistent execution, and then as the systems become more intelligent, you'll be able to get to that more headspace for people, right? What are your thoughts, Francis?
Yeah, that's an interesting one, very interesting. At the beginning, all you want is really just achieve some consistency and being able to repeat always the same thing in the same amount of time, yeah? And then eventually you find that, well, hang on, actually, I can actually take some shortcut here and there. I can, shorten the time to do this, to do that, and you discover that actually these things that you were doing that were not necessary. And we're thinking always of, after you finish drilling your stand, before making your connection, there's all sorts of practices there. And, people would backcream a stand, backcream half the stand, or maybe not backcream at all, but circulate, 10 minutes, 2 minutes, whatever, yeah? And so first you bring consistency, and then you actually start realizing, well, really, I don't need that. I'm doing just fine. Now, of course, you need some other level analytics. It's not just the automation there, it's the analytics and the help to the decision-making that happens behind those analytics that allow you to create new space for performance. Yeah.
If I may add, Nils, what people quite often refer to some disciplines like directional drilling, like an art as much as a science. And if you want consistency in this, it gets difficult because you need to somehow replicate that decision making. And so you can do it. But it requires much more efforts than simple what we would call automation. So autonomy requires you to be able to modelize, have a model of that decision making process, and learn from the different practices around the world. Yeah.
Yeah, that's an excellent point you mentioned there, Alex. The sort of modeling that decision making process and how we humans think and perform and make decisions. And another comment coming in from LinkedIn is, how do we ensure that automation is also the most optimum option? So that brings me to another question. Is really, so you mentioned that the level 4 definition of autonomy is multiple workflows that are integrated at the well site. So I'm thinking, we mentioned directional drilling, mud logging, drilling fluids, for example. This move to autonomous systems requires us to also look at how we manage contracts and how contracts for different services are specified. I'm thinking, for example, drilling fluids, where the contract's built around API standards, and we had to make drilling fluid measurements around those standards, and that complicates significantly the automation of the drilling fluids management system. So my question really is, do we also need to look at how do we manage and contract and specify work at the drill site?
So, okay, Francis, go ahead.
Yeah, Nils, thank you for that. Yeah, I think you're absolutely right. But I think this is going to come. It's going to come from multiple ends. There cannot be autonomy without the involvement of all. And by all, I mean, the service companies. You talked about the drilling fluids, but also the drilling contractors, very important. OEMs, those rig manufacturers. So there's going to be a level of involvement from everyone for this to be happening. Yeah. Now you mentioned about the API contracts that you are required to make so many samples of the mud and so take so many measurements. It won't be long before we have a fully continuous measurements of the drilling fluid by machine. This is happening. So obviously contracts will have to adjust for this. Yeah. But I think if anything, all of this is going to tend towards more digitalization and more performance contracts. This is in the making for sure.
Yeah, thank you. Performance contracts. So Alex, do you want to add to that?
Yeah. So we see that interface is a critical element when you want to install such systems. So it will get more and more complex. It will require a lot of collaboration. I think we can see that collaboration happening on the data side. We need to have similar things on the automation side and building on that data collaboration environment, and that will ensure that our systems are safe. But then for certain workflows, if you really want to get all the way to level 4 or 5, that will require quite a lot of work to make sure that those interfaces cover all the different cases. And but we have some experience on that, so I think we can see where this can go. Yeah.
Perfect. I'm going to come back to a little bit about decision making shortly and what the criteria are behind that. But good comment or sort of question from David Farmer on LinkedIn. Majority of well construction time is around pipe handling, essentially, and also moving from well site to well site. How do you take that into consideration in terms of this system?
So I can take this one, Neil. So I think that's where we haven't presented that today, but there's, when you look at the software stack that comes into play in building an autonomous ecosystem, if you will, there are different ways to address all the aspects of autonomy. And what I think what David is referring to leads more towards that surface automation, where this is actually a task that is pretty repetitive. So you can have a surface automation system that will take care of that, whereas a more you leave some of the intelligence more for well construction. So that pipe handling, for example, is will be mostly driven by a surface automation machine, but with some input from the intelligent execution. For example, if you need to have some limits in how fast you trip, how fast you run casing, etc. So I think if you look at those different blocks, each block addresses a different aspect of the full automation. The real challenge in building that autonomous system is the cost and the return on investment for all the players involved.
And add something there, Nils, if you
please, yeah.
Within the context of David's question, this has a lot to do with mechanization, really, mechanization of the rig. Yeah. But remember, earlier on we talked about, the delegation of decision making to the machine. Yeah. Now, where does that come into play when you're actually on flat time, tripping in and out and picking up and laying down pipe? Well, that goes into, other processes where you can actually automate, the detection of anomalies, the detection of dysfunctions. What are the problems? And that well control events happen when for most of them when you're swabbing the well, yeah, not when you're drilling so much, yeah, in terms of statistics. So you're gonna have ways to look at the stuck pipe, when putting the pipe out. So there's some level of automation into the detection of the problem, yeah, because this is where most problems happen.
Yeah, perfect, Francis. Thank you. So that brings me back to a sort of a question and sort of some comments you made earlier. So, so the criteria behind the decision making. We talked about being either in repetitive environments. So, for example, pipe handling versus non-repetitive environment, subsurface. So, how is that going to, do you think, impact the criteria behind decision making and risk sharing, for that matter?
Okay, so it's quite an interesting activity to have to model those decision making. So there's different ways to do that, but I think it requires a lot of interaction between the métier, the disciplines, and the development team. And so what we've realized is when we build those systems is that we think we get it right, and we get it mostly right, but when we start implementing, we learn a lot from the interactions from the different people that we interact with, because in certain areas, the practices will be different. So I think the good news is that your system, only gets smarter by doing that. The challenge is to keep that model simple enough so that it's something that is easy to code, something easy to fill, for the user, and something easy to read and understand for someone who's not being part of the process. And lastly, it's also about making sure that your planning system are able to help you in setting up that system, so that what are the limits that you use to drill that well is something that comes from the planning and allows you to drill that safely and with some performance. Thank you.
Francis, do you want to add to that at all?
No, I was just thinking, when the planning comes in, it's really a big part of it. I was thinking of, the infinity sign of planning cycle, and you plan, you execute, and you learn, yeah. And all of that is going to be simple enough so that you can actually have better adoption of the full cycle of it to realize all the value.
Thank you. Really great conversation. So I just want to bring up a sort of kind of final question here is sort of, what is the main objective of the automation or the autonomy technology that you're driving at here?
So I think we have different objectives. I think, but one main objective is that we make that operation safe and more cost effective. We'll see different, I think, operating models as we go, but I think they will support that evolution from the current state, the state we're currently in, to a state where every foot that you drill, every well that you drill, you learn from it, and you learn very quickly, and you're able to implement those learnings very rapidly, so that you're in a continuous improvement cycle, with the objective of making operations safer and more cost effective.
Yeah, we often hear, Nils, is your objective to get to the level 5 and full autonomy? Yeah, this is something that comes back as being an objective. I don't think, in our industry, and of course the answer is it depends, but in our industry, I don't think there's a lot more value. There's so much more value to be realized already at the lower levels of autonomy, without saying, hey, our objective is to get to full autonomy in so many years. Yeah? There's plenty to be made along the way on the journey. And as we add additional workflows, more and more value will be realized.
Yeah, I think we can say that we need to create value from day one. I don't think it's a science project. It's about creating value for everyone in the industry from day one.
So perfect. I mean, I just love what you're saying here. Basically, we're on a journey. It's about continuous improvement, risk reduction, improvement in safety, also a significant focus on cost reduction through greater operational efficiency. Great comments from the audience, by the way, so thank you, audience. Just one last question. Can you guys share any results from implementing autonomous systems that the audience can sort of take away and think about?
Do you want to start, Francis? Or
sure. Yeah. So we've been going through the various building blocks of autonomy there. So there's various examples of various ways. If I just talk about the surface automation, for example. So we have various rigs that are automated already in the world, and what we find is you got to go through an adoption phase, yeah. But once the adoption is there, when people are embracing the system, we find very, very consistent improvements and increase in performance. And I've got some examples, of 2 rigs that had been drilling for years, and we enable them to use drill ops or automation system. We find ROPs that are increased by 25%, and as best of the best drilling curve beating, yeah. Downlinking times as well, that is wasted time really, and that's reduced by another 25%. The pre-connection times, post-connection times, this is something that is extremely dependent on who the driller is. It changes if you're night driller and day driller, yeah. Now those were reduced on average by 30%, yeah. So these are little seconds that add up to a lot of days in the end of the year, yeah. Now if we talk about as well management, integrity management, or reduction of NPT, we find that the NPT generated by stick and slips, shocks, vibrations on the BHA, all of that was actually reduced by 90%. Hold on to your seat. 90% reduction by having the system. So that's really a proof point of how this works. Yeah.
Yeah. So Nils, I think the good news there is that we can see proof points in all the different blocks that we presented before. Whether you look at surface automation, intelligent execution, as Francis has said, we can also mention in the planning, our intelligent planning tool allows us to plan for wells that we didn't think were possible before, with dot severity that we didn't think were achievable. And also in downhole automation, if you are able to implement downhole automation as we were in some of the various implementation we've done, in different areas of the world, but whether it's the US or Middle East, you can see, downlinking being almost reduced to zero, and also additional ROP increase brought by those downhole technologies. So I think it's it's very exciting to see the proof points from all the different blocks, and putting them together will make them even greater.
Francis and Alex, thank you very much. Very, very exciting to hear all this. These powerful incremental improvements, as you said, you just mentioned now, so some substantial savings and through improved efficiency. So a very, very exciting journey ahead for automation and drilling autonomy systems. So thank you very much for sharing your insights and expertise today. It's been very, very interesting to hear. Thank you to the audience. You've been great. Really great comments and questions coming in from the audience. Now, I understand there'll be more about automation from Schlumberger at the upcoming SPE IADC Virtual International Conference and Exhibition, which is taking place next week. So please check that out. But once again, Francis and Alex, thank you very much for joining us today here on SPE Live. It's been a pleasure talking to the pair of you. Thank you.
Thank you, Nils, for having us.
And thank you also to Schlumberger for sponsoring this SPE Live, and also to the SPE Foundation for making SPE Live partly possible. So thank you. And to everybody today, have a great rest of the day. To the audience, thank you very much for participating. Catch us later on SPE Live. We have more great content coming later today and later in the week. So see you all then. Thank you very much and have a great day.
Well, this is the main drilling event for our business throughout the world. It alternates between the US and Europe, obviously. And this is where the drilling people really come together to talk about what's changing, what's new in our industry, how do we improve, how do we get better all the time. So this is the big event for the drilling community.